Hello everyone, we are back with another interesting problem. This time, the problem is dealing with circular motions. The setup is as follows. There's a smooth, there is a smooth surface upon which a very small bead is carrying out a circular motion. It has a velocity that is constant in along the tangential direction, that is v naught. A hand is holding the string at an angle theta, and suddenly it's given an initial acceleration upwards of magnitude a naught. We are given the length of the string to be L. The conditions are: 1. Bead does not leave the floor. What does that mean? It means that the acceleration of bead in the vertical direction, let's just say a perpendicular, must be zero. We can also assume safely that string remains tight throughout the experiment. Why is that necessary? Because a slacking string will cause unexplainable effects on the system. Okay, so our final question is to find the magnitude of the acceleration immediately after the upper end of the thread is pulled. How will we approach the situation? First, in a circular motion, the an object is carrying out a motion with velocity v. It experiences a centripetal force um, with acceleration v naught square by r. Here r must be L sine theta. Secondly, because of this thread, which is given an acceleration a naught upwards, the component of this acceleration along the length of the string must be a naught sine a naught cos theta, right? Which is translated across the string. Now we are left with two situations. One that seems more obvious is we resolve acceleration in perpendicular and parallel directions. This a naught cos theta, we can take its components across the horizontal and the vertical directions. This is theta, it must be 90 minus theta. So this would be a naught cos theta sine theta, and this would be a naught cos square theta. Okay. Or secondly, we can consider this, that this acceleration a naught cos theta is actually a component of another acceleration vector, let's just say a dash, across the radial direction. Which one of the two situations must be true? For this, we need to go back to our initial condition that the acceleration in the perpendicular direction needs to be zero, which means that if we consider this to be the original acceleration, we will end up having a vertical component of the acceleration, which directly contradicts with our initial conclusion. So we go forward with the second condition, and we'll assume that there is an acceleration caused because of this pulling in a radial direction, let's call it a prime, whose component across the string is a naught cos theta. This will lead us to a situation where a prime is equal to a naught cos theta upon sine theta, that is a naught cot theta. Combining these two accelerations, we conclude our final acceleration to be v naught square by L sine theta plus a naught cot theta. Thank you.